Hey, it's Mr. Kabbalah. In these geometry recap videos, I'm trying to focus just on the most important topics in each lesson. I hope they're a help. Let me know if you have any questions.
All right, this is going to go over Unit 8, Lesson 3. It's the recap for trig and the calculator, and I wanted to go over what is the calculator actually telling us when we do these trig ratios. So when we type in sine 50, and again, sine is right down here, sine 50 gives you the decimal 0.766 and so on. What does that really mean, though? So if we have a right triangle, so there's my right angle here, and we know that one of the angles is 50 degrees, and we call these the acute angles because in a triangle, there are 180 degrees, and if one of them is taken up by 90, this one, then the other two can only share another 90 degrees, which makes them acute. So if we know that one of them, let's say this one is 50 degrees, and we know that the hypotenuse, so across from the across from the 90-degree angle is the hypotenuse. If we know that has a length of 1, then we also know, and this is what the calculator is telling us, that this side right here, this blue side, has to be equal to the sine of 50, which is 0.766 and on. Okay, it can't be more than 1 because the hypotenuse is the longest side of a right triangle. So that's what the calculator is telling us. It's kind of like a unit rate. It's comparing the opposite compared to the hypotenuse if the hypotenuse is 1. And if you remember, a unit rate has a denominator of 1. Now this is for sine, and you can kind of see we can label these either with a decimal value or with just the sine of 50. The sine of 50 is that decimal value. Okay, it's not referencing an angle, it's referencing a length of a side of a right triangle. So if we do cosine 50, similar, cosine is right here. We get 0.642 and on and on and on. In terms of a right triangle, if we know that it's a right triangle, and we know that the side opposite, namely the hypotenuse, has a length of 1, and we have this 50-degree angle, so same angle as before, then what we know is that this side that I've highlighted in red has to have that 0.642 and on decimal value, or the cosine of 50. Again, it can't be more than 1 because the hypotenuse is the longest side of a right triangle. So 0.642 is less than 1. Now if we look at them side by side, again, we can have the decimal value, now I rounded this, 0.643, or we could just call it the cosine of 50 because that is the decimal value. Tan of 50 is similar. Now tan is right down here. Now we get 1.19 and on and on and on. Excuse me. So what does that mean? Again, if we have a right triangle and we know that one of the acute angles is 50 degrees, now this time instead of the hypotenuse being 1, we're going to set the adjacent side to 50 degrees equal to 1. Okay, so slightly different there. What that tells us, or what this tan 50 tells us, is that this side, so again this blue side, has to have that value that the calculator gives us, 1.19 and on and on. Okay, and this is a unit rate comparing the opposite of the 50-degree angle compared to the adjacent side. So that's the tangent, opposite over adjacent. This can have a value greater than 1 because the opposite side can be bigger than 1. Now, if we were to go through this and find the hypotenuse, it would have to have a length longer than 1.19 because, again, the hypotenuse has to have the longest side, or the longest length. So again, looking at these side by side, we can use the decimal value or that tan of 50, because the tan of 50 again is a length, not a degree of an angle. Now what can we do with this? So let's go back to the sine of 50. Again, the sine of 50 was 0.766 if the hypotenuse has a length of 1. Now keep in mind that we can call 0.766 the sine of 50. Let's get rid of a few things here, and then let's shrink down that triangle so that it's just a bit smaller, and then let's enlarge that triangle. Let's scale it up. Let's dilate it so that the hypotenuse actually has a length of 8. So here's our 50-degree angle, 50-degree angle, 90, 90, which means that they're similar triangles. If two angles are the same, then the triangles are similar, which then means that we have sides that are in proportion. Okay, that's what similarity means, that the side lengths are in proportion. So what can we do? We can take this triangle here, the smaller one, and make a proportion comparing the opposite side of the from 50 compared to the hypotenuse. Opposite over hypotenuse is sine. So 0.766 compared with 1, its hypotenuse, is the same as comparing the opposite side of the dilated triangle to its hypotenuse, which is 8. Now we're going to cross multiply, but before we do, just remember that 0.766, and I'm going to actually change it out right here, we can actually call that sine of 50. The sine of 50 is that decimal value. Now to solve proportions, remember back to 6th or 7th grade, we can cross multiply. 8 times sine of 50 equals 1 times x. Now sine of 50 again, I'm going to replace it back with that decimal value, 0.766, equals 1 times x, and that's x. Basically, I'm just solving an algebraic equation for x. Sometimes we multiply, sometimes we divide, but you'll see that later on. Okay, on our calculator, we could either type in 8 times 0.766 or 8 times sine 50. They would give us the same thing. 6.128, which means that this side length here has a side length of 6.128. And again, it has to be less than 8 because 8's the hypotenuse, which has to be the longest side of that right triangle. So when we are typing in these trig ratios into the calculator, it's giving us a unit rate, and we use that unit rate to set up and solve proportions. So the trig ratios are unit rates comparing specific sides of similar triangles. The triangles are similar because they both have 90-degree angles, and they both have another angle that's the same, one of the acute angles. When we type in sine 50, for example, the calc is telling us the length of the side opposite the 50-degree angle of a right triangle if the hypotenuse is 1. Again, for example. We can use this to set up and solve proportions to find the lengths of other sides of similar triangles. So I'm just trying to show you what is going on when we use the calculator and the trig ratios and what's going to be coming up next. So hopefully this didn't confuse you further. Hopefully you're doing well, and we'll see you some other time. Bye now.